Let us solve this pair of simultaneous equations using matrices. Now, let us call this, if we want, equation 1 and this equation 2. Alright? The first thing to do is to rewrite the equations in matrix form. We have 3x plus 7y equals 47. That's equation 1. Equation 2 says 2x plus 4y equals 34. Now, in matrix form, we have the numbers here. 3, 7, 2, y multiplied by, why I write y there? It's not y. 3, 7, 2, 4. Right. Multiplied by x, y. Right. It's 3, 7, 2, 4. Multiplied by xy equals, and that's another matrix to represent these numbers over here. 47, 34. Good. You have that matrix. Now, what we really want is to know what x and y equals. So we have x, y. What will those be equal to? The thing is, if we should have another matrix here, and for argument's sake, say you have 5, 16 here, then you would conclude that x is equal to 5 and y is equal to 16. Right? That's why I put the x, y equals. Now, how is this going to work out? Suppose you have, for argument's sake, 7x equals 21. What you would do is divide both sides by 7. Divide by 7. Then 7 would cancel 7. You would have x equals 21 over 7, 3, and you solve x. It's something kind of similar that you're going to do here. So, if you should, for argument's sake, divide both sides by 3, it's in black. If you divide both sides by 3, 7, 2, 4, divide here by 3, 7, 2, 4, then 3, 7, 2, 4 will cancel 3, 7, 2, 4, and you're left with xy equals 47, 34 over 3, 7, 2, 4, right? Now, being that this is what you have, let's go back to this example. When you have 27, now when you have 21 divided by 7, it's the same thing like saying 21 multiplied by 1/7. You see that? Same thing like saying 1/7 times 21. Now this is the same as the inverse of 7 times 21. You see that? Now, let's apply that argument to these two matrices. This is like saying you have 47, 34 multiplied by 1 over the matrix 3, 7, 2, 4. Same argument applying, right? Applying that argument. So it is, I could further argue that it is like 47, 34 multiplied by the inverse of 3, 7, 2, 4. 3, 7, 2, 4 inverse. Alright? Now, if you try to multiply 2 by 1 matrix by a 2 by 2 matrix, it wouldn't work. But you could multiply a 2 by 2, putting it a 2 by 2 first and the 2 by 1. So if we put 3, 7, 2, 4 inverse first, and then the 47, 34 after, then things could work out for us. If we should find the inverse of a 3, 7, 2, 4 and multiply the 47, 34 matrix, then we could have some hope of solving and finding x and y using matrices. So let's just use that method and see if we can solve it. Let's erase these things to make some space. So what we have is this and this. Let me be careful now. Erasing this. Nice. I erase all of these things. This slash across here. Let me erase this and put it back without the slash. Alright. So what I have here now is 3, 7, 2, 4. Now, from what we saw a while ago, what I really want to do here is say x, y is equal to, it's going to be 3, 7, 2, 4 inverse multiplied by 47, 34. Alright? So now, let us find the inverse of 3724. Remember now, it will be 1 divided by the determinant, or let's write it using the other method. The determinant of 3724. Remember, the straight lines on each side means determinant, right? And that will be multiplied by, remember what to do now. You interchange the leading diagonals, 4 up here and 3 down here, and you multiply the non-leading diagonal. You interchange the elements of the leading diagonals and multiply the elements of the non-leading diagonals by -1. So -7, -2. So you interchange A and D, change the sign of B and C if you had it in the form A, B, C, D. Now, what is the determinant here? Determinant, you multiply 3 and 4. 3 4 is 12 minus 2 7 14. Nice. So the determinant is that. So the determinant is 1 over that, 3. 3 by 4, 12 minus 2 7 14 is 1 over -2. So being constrained for space, let us just erase this and write the 1 divided by -2. Alright. And that will be multiplied by 4, -7, -2, 3. So you see what we have so far? We have 3724. We're going to invert that and multiply it by 4734. So we say 1 over the determinant, 3 of 3724, times interchange 3 and 4, the leading diagonals. 4 come up here, 3 come down here. Multiply the non-leading diagonal elements by -1. So we have 3 4s, 12 minus 2 7 14, 12 minus 14 is -2. So we have this to multiply. Let's put them a little closer since we are fighting so much for space. Let's put these numbers a little closer and use the space over here. So what we have is -½ times, these dots sometimes just come up. I have to erase them. 4, -7, -2, 3. Alright, so we're going to multiply -½ by each item inside the bracket. -½ by 4, is 4 over negative 2. And you have negative 7 times negative half is positive 7 over 2. Negative 2 by negative half is a positive 1, because it's going to be half times 2 is 1, and negative by negative. And then you have 3, negative half by 3 is negative 3 half, negative 3 over 2. Alright, so that's what you have. As this is the inverse of 3724. So now, let's see what we're going to have. X, y is going to be equal to negative 4 over 2 is what? It's negative 2. So let's just write negative 2. It's negative 2, 7 over 2, 1, negative 3 over 2. And that will multiply 47, 34. Alright? Let's try to squeeze our work in the little space that we have down here. So x, y will be equal to, remember now, row times column. You multiply negative 2 by 47. This kind of look like 41. Let me put this tick on top of the 7 to make it clear. Negative 2 by 47, that will bring you negative 2 by 47. 2, 7 is going to be a negative. 2, 7, 14. 4, carry 1, 2, 4 is 8, and 1, 9. So it's 94 plus 7 over 2 times 34. 7 over 2 by 34, right? 2 into 2, 1, 2 into 34, 17 to 34 is 17. We're going to be 17 by 7, 17 by 7, 17 by 7, 7 7 is 49, bring down the 9, carry 4, 7 1 7, 8 9 10 11, 119 here. And then that's what you have up top. Alright? Down the bottom here, 1 times 47, 47 plus negative 3 over 2 by 34. Let's work it out over here. What is negative 3 over 2 by 34? It's going to be a minus anyway. Plus negative. Might as well I just put minus here. 3 over 2 by 34. 2 into 2, 1, 2 into 34, 17. And then 3, 7, 21. Bring down the 1, carry 2, 3, 1, 3, 4, 5, 51. Alright, so let's see what's going to happen. Negative 94 plus 119. What's that equal to? It's going to be the same as 119 minus 94. So 9 minus 4 is 5. Right? 9 minus 4 is 5. 9 minus 11. 11 minus 9, that's 2. So we have 25. And then after that, 47 minus 51. 47, 45, 50, 51. That's 4. Alright, so let's retrace. We have 3724 xy 4734. So we say xy is equal to the inverse of 3724 and multiply by 4734. So to find the inverse of 3724, we have 1 over the determinant. We say 3 4 is 12 minus 7 2 is 14. So 3 4 is 12, minus 7 2 14. 12 minus 14 is negative 2, so it's 1 over negative 2. Interchange 3 and 4. Change the sign of 7 and 2, good. And then we say this negative half times what we have here. This becomes 4 over negative 2, which is negative 2 here. Negative 7 over 2. Negative 2 over 2 is 1. 3 times negative half is negative 3 over 2. Multiplied by 47/34. Good. So we say negative 2 by 47. That's going to be negative 2 by 47. 2 7 14, bring down the 4. 2 4 is 8. And 14, bring down the 4. 2 4 is 8 and 1 9. So that's negative 94 plus 7 over 2 times 34. So 2 into 2, 1, 2 into 34, 17. 17 by 7. And we got 17 multiplied by 7. We're just making sure we didn't make any mistakes. 17 by 7, 7 7 49. We bring over the 4, 7 1, 7 8 9 10 11. So it's 119. So we have 119. Then negative 34, negative 94 plus 119 is the same as 119 minus 94. Here, 9 minus 4 is 5. Then we have 11 minus 9, 2. So you have 25 up here. Alright. Then, after that, what we have here is going to be 47, which is 1 by 47 times plus negative 3 over 2 times 34. 2 cancels 34 to get 17. 17 by 3 is 51. 47 minus 51. 47 minus 51 will be negative 4. Negative 4. So what you have is 25, negative 4. Alright. So if we get 3x plus 7y is 47 and 2x plus 4y is 34 and we get 25, negative 4, what we can do is do a little test. Once we solve any pair of simultaneous equation, we can always test it to make sure everything is all right. So let's do our little test here. If this is so, then x is 25 and we say 3 multiplied by 25, and if this is the case, y is negative 4. So we say plus 7 by negative 4, so we minus 7 by 4 equal, and we get 47. Equation 1 works out so far. Let's try equation 2. Let's clear the screen. Try equation 2. If this is what we say it is, y is equal to negative 4 and x is equal to 25, it should work out for equation 2 as well. 2 times x, which is 25, plus 4y, plus 4 times negative 4 is going to end up as a minus. Minus 4 times 4 equal, and we get 34. So the equation does work out. So that's how you solve a pair of simultaneous equation using matrices. Alright? I want you to make a note of this in these things in your notebooks, but I want you to try to do this again without looking back at your notes to get the answer. So the final answer we get is let's write it here. X equal, all right, let's not use this color. We have our answer here. Let's put our answer in a nicely packaged gift wrapped box, and we say X equals 25, Y equals -4. So that's our answer.